with example 3 with how to take derivative using the limit definition of a derivative. And that limit is the following. The derivative of a function f is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And the function, which I should have called f of x, equals the square root of 2x plus 4. In order for me to go over this example, I'm going to need my marker. There it is. This function is going to be a little bit more difficult to deal with because we have that square root. So our derivative is going to equal the limit as delta x approaches 0 of f of x plus delta x. Now if I plug in x plus delta x into the function right there, that'll give me the square root of 2 times x plus delta x plus 4 minus the original function f of x, square roots of 2x plus 4 all over delta x. Now it's okay if you have trouble understanding the step from here to here, pause the video, really take a minute to look over this, as this part is actually pretty difficult. Now in order for us to find this limit, you should have seen earlier that we have to use what's called a rationalizing technique. And that allows us to clear those square roots. So I'm going to rewrite the problem and I'm going to show you how we're going to use the rationalizing technique. That technique applies an idea that you may have learned with imaginary numbers in Algebra 2 called the conjugate. And we're going to take this limit and multiply it by the conjugate of the numerator, and that is the square root of 2x plus delta x plus 4 plus the square root of 2x plus 4. If you're seeing this for the first time, then this might not be the best video for you right now, but this technique is called the rationalizing technique, and like I said, I'm multiplying by the conjugate. The reason why this works out nicely is now we have this form of a minus b times a plus b, which typically in algebra will equal to a squared minus b squared. That is going to allow us to clear the square roots from the numerator. So our numerator ends up being just the exact same thing but with no square roots. 2x plus delta x plus 4 minus 2 parentheses 2x plus 4 all over delta x times that whole conjugate that we multiplied to the top and bottom. Now don't simplify that, don't do anything to that, keep it as is, as we're going to find that it simplifies nicely in just a little bit. Plus square root of 2x plus 4. Now in the numerator, I'm going to have to do a few steps all in one shot. I'm going to distribute the 2, so that gives you 2x plus 2 delta x plus 4 minus 2x plus 4. And if you see that carefully, things are going to cancel out. The 2x is going to cancel with the negative 2x here. The 4 is going to cancel with the negative 4 here, leaving me with just a 2 delta x in the numerator. All over delta x times that whole conjugate that we multiplied the numerator and denominator by. So square root of 2x plus delta x plus 4 plus 2, square root of 2x plus 4. This allows us to cancel our delta x's, so delta x's go away. And we could do our direct substitution of the 0 for the delta x. And since I've run out of room, I'm going to put in a few more steps all in one here. The numerator ends up being 2 over the denominator, allowing delta x to approach 0 here, ends up being the square root of 2x plus 4 times the, plus the square root of 2x plus 4, which leaves us with 2 square root of 2x plus 4. And I do have an extra parenthesis here that shouldn't have been there. That is my fault. There's an extra parenthesis that shouldn't have been there. The 2 is actually reduced, and we end up with our derivative, and hopefully this still comes up, as 1 over the square root of 2x plus 4. And here, what we did, we found the derivative. Our derivative allows us to find the slope of the original function, and that's how we do this one. Thank you very much.